Okay, hello all. Can you hear me?
Yes, ma'am.
Yes, ma'am.
Yeah, okay. Uh, so I'm starting with the discussion on Bode plot. Now, as per your request, I'll explain from scratch what the topic is all about. This is just a session for a trial session. If this works well, if you are able to understand it properly, then we will continue with this format. Otherwise, we will try to find out something else. Is that fine?
Yes, ma'am.
Okay,
Yeah.
ma'am.
What exactly are you seeing on your screen?
There is a PPT.
And do you see a window as well for the participants?
Yeah, and a group chat.
Okay. Just a minute. Okay. So I'm going to mute all of you. Okay, because at your ends, if you have some noise, it is disturbing for me. So I'm going to mute all of you. If you have any difficulty, there is hand raising option for you, available for you. Can you see all of you?
Yes.
Can all of you hear me out?
Yes.
Okay.
Yes, ma'am.
Okay. So you have hand raising facility at your end. If you have any
Yes.
difficulty, just stop me there. Or if you are not able to find it out, just write it in the group chat so that I can address your difficulty. Okay. Yeah. Okay. So we'll start with Bode plot. It is basically a frequency plot, which is plotted versus frequency, I mean against frequency. So there are two different plots in Bode plot. First plot is magnitude plot and another plot is called as phase plot. So we have here on the screen, you can see Bode plot, combination of two plots with magnitude. This plot will have magnitude versus frequency and phase plot will have phase versus frequency. Now in this magnitude as well as phase plot, we have a transfer function and we have different factors of the transfer function. We'll see on the next slides. So basically a magnitude plot and phase plot are addition of magnitude contributions by all the factors and addition of phase contributions by all the factors. So that makes it the whole Bode plot, what we can say. Okay. Okay. Now, the factors of transfer function. So, when I say that it is addition of all the contributions of magnitudes and phase, we need to understand what the factors of transfer function is. The example is given on the slide. GSHS is equal to 10 into S plus 1 upon S plus 10 into S plus 100. Now in the above example, the factors of transfer function are K equal to 10. This is a separate factor. First order 0, which is S plus 1. I hope all of you understand what is first order and what is second order now. When we have power of S as 1, then we can say that it is first order function, and power of S is equal to 2, then it is second order function. Now, in this example, we have 10 into S plus 1 upon S plus 10 into plus 100. Now in this case, what we have is k is a separate factor, s plus 1 is a separate factor which is known as a first order 0, and there are two first order poles, one is s plus 10 and another is s plus 100. Now what we were talking about, the contributions of each factor and then addition of them, is nothing but the whole Bode plot will be formed by magnitude contribution of this factor, this one and this one. Similarly, phase contributions of all these factors are taken into consideration for plotting the phase. Okay, I hope all of you are clear with this till this point. So all the above factors contribute in magnitude and phase of the transfer function separately. Now collection of all the contribution forms a Bode plot. Now in this case, if you go further, the scales used. Now what the scales used are, scales are nothing but scales on the x-axis as well as on the y-axis. So on the x-axis we have a frequency. Obviously there are two different plots, magnitude plot and phase plot. In both the cases, x-axis pe frequency hogi, that is logarithmic frequency. Now why are we using logarithmic scale on the x-axis? There are certain advantages. Those advantages are stated here on this slide. First advantage is frequency is expanded at origin. I'll explain what this is. Large span of frequencies can be covered and multiplication and division become addition and subtraction. I hope all of you are clear with the third point. Log of two numbers, if those two numbers are multiplied, then you can add logarithms of those two numbers. Instead of multiplication, you can add them. I hope this is clear with you. So multiplication becomes addition and division becomes subtraction in case of logarithms. So that makes it easier for the computations. First two advantages, what we were talking about, large span of frequencies can be covered. Now on your scale, suppose now this is your semi-log paper, we call it as semi-log paper. On x-axis, you have logarithmic scale and on y-axis, you have linear. Now, when we are talking about this logarithmic scale, this frequency is logarithmic frequency, right? So at one point, the frequency is say 0.1. Then next, we have 0.01. Then we have we have 1. Then we will have 10. Then we'll have 100, 1000. So in one semi-log paper, you can include all the frequencies from 0.1 to 1000 and beyond. You can consider the starting point as 0.0001 and then go on adding the frequencies, right? So because when we have, suppose we are using a linear scale and we are using a graph, normally a graph paper. So 1 centimeter is equal to 1 unit, right? In this case, 1 unit would be 10 times whatever the starting point is. So that is why large span of frequencies can be covered. Instead of logarithmic scale, if you are using linear scale, then suppose 0.1, 0.2, 0.3, 0.4, up to 1 you will be considering. But in semi-log paper where we have logarithmic scale on the x-axis, we can cover large span of frequencies starting from say 0.1 up to 1000, 10,000, whatever you like. Okay, so that is an advantage. And so frequencies are expanded at origin. That means instead of having 0.1, 0.2, 0.3, we directly have 0.1 and then we can have 1. In between, we have sufficient space to plot the points, which we will not have if you have linear scale. Okay, so that those are the advantages of using logarithmic scale. Logarithmic scale is on x-axis, which is frequency. Linear scale on y-axis, which is or phase, depending on we are using magnitude plot or phase plot. So now Yes, all of you. Is this screen visible? I got a message that screen is not visible.
Yes, ma'am. Screen is visible.
Yes, ma'am. It is visible.
Yeah, Ishita.
Yes, ma'am.
Yeah, is this screen visible? Was it visible, the PPT?
No, ma'am. No, ma'am.
It might be the difficulty at your end. Check your internet connection. Rest everyone. Is this screen visible?
Yes, it was.
Yes, ma'am.
Yes, ma'am.
Deepa.
Screen is not visible.
Screen is not visible. I think the problem is with the internet connection only, because for some of you the screen is visible. Okay, what you can do is you can check your options on your screen. Okay. Can you see the start video, mute, all the options? Are the options on? Appropriate options?
Yes, ma'am.
Okay. Now I'm going to put the screen back. Okay. Just check whether you can see the PPT or not. And just let me know in the chat section. Can you see the screen now?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
What about others?
Yes, ma'am.
Okay. Okay. Have you understood what did I explain till now?
Yes.
I think Shivam,
Yeah.
you can check on your group, because I'm not getting responses from everyone. Deepa.
No, ma'am. Not clear. Audio is also interrupted.
What is interrupted?
Ma'am. Uh,
Hari
Ma'am, on
Priya.
our WhatsApp group, there are messages like means there are no sound coming or sound issues and screen is not visible. Like
I think that is the problem with the internet connection. I can't help it now. I mean, at their end, the internet connection must be,
yes,
I mean, sufficient bandwidth must be available.
Yes, ma'am.
Is it visible now?
Yes, yes, ma'am.
What are you seeing on your screen right now?
M means not
Okay.
PPT but audio.
No,
is
I'm not. I
linked.
have not put the PPT yet. But when I PPT just now, I had put. Did you see that?